Hello everyone. We will start on time because we will probably need the full 30 minutes for the talk. Usually I do it in an hour, so it's going to be a rough ride anyway. Higher? Okay, yeah. Please tell me that because I'm also not used to holding these things. Usually they're attached to my head. So if you don't understand me, then yeah, you're my microphone guy, okay? Good, thank you. Okay, then let's get going. So I will give you a quick introduction. I will tell you briefly how SUSE Linux works, explain to you why we did the change, and also what it does mean for you based on different scenarios. And then depending on time, I will show you a bit of a confinement demo. Still too? Okay. Can you please close the door? Better? Okay. Yeah, sorry, I was standing back there in the last session. It's super hard to hear in the back. So, okay, good. Then let's get going. Quick introduction. My name is Johannes Segitz. I'm a security engineer. I work at SUSE, live in Nuremberg in Germany. I do code review, although not that much nowadays anymore because I like uninterrupted time. It's kind of changing with the AI tools nowadays because I kind of find security bugs by accident by just testing them. I do product pen testing, so before you get a SUSE product, we test them from an offensive point of view and see if we can break them. I'm an SUSE Linux expert, that's the reason why I'm standing here. And I'm also the lead of the proactive group where we do all of the code review and hardening before we release a product. So let's jump right into SUSE Linux. Before we discuss SUSE Linux itself, let's talk about discretionary access control so that you see the difference. Discretionary access control is the usual form of access control that you all know from Unix-like systems. So you see a typical example here. I listed the etc shadow file here. And if you add the flag -L, then you see the full permissions here. And we see the file belongs to the user root and to the shadow group. And then you see these access permissions here. So root can read and write, and the shadow group can read, and everyone else can't access this file. So that's the normal form of access control. I'm pretty sure that you've all seen that. Since it's a technical talk, I expect that you're all kind of technical. It has a couple of drawbacks. So first of all, it's pretty coarse. You basically have these 3-bit masks. And yes, I know there are more, and you can do access control lists. But in the end, a lot of access control is still done via these 3-bit masks. So reading, writing, and execution. It is prone to user error. So nothing on your system to prevent you from getting into a situation like this, where I made my private SSH key read and writable by every user on the system. Sooner or later, your SSH client will complain because it actually checks the permissions and tell you don't do this. But at this point, it's already game over. So nothing really protected you from making this mistake in the first step. Then it's also pretty hard to analyze, because if you want to reason about this, first you need to get all of these access permissions, so you need to walk the file system. If you have a huge file system, that can take some time. So this is problem number one. You don't really know if the state of the system still is the state you're looking at when you get these permissions, because it might have changed in the meantime. Also, you're looking at a very low-level representation of what you're trying to do here. There's no abstraction here. It's basically telling you the individual bits, not what you actually wanted to do with them. And then you have the fact that the root user on Linux systems is basically God. We kind of try to split this up with capabilities, but that did not work out too well because half of the capabilities are full root and the other half is kind of useful, but didn't really work. So let's go to mandatory access control. The operating word here obviously is mandatory. So access control decisions here are not made by the owner of an object, but you have a centrally managed policy that specifies how access works. So in the previous example, for example, I could have something in my policy that specifies that private SSH keys can't be readable by everyone in the system, and then I can't change that even if I'm the owner of the object. That has a couple of advantages. So you can put the access control in the hands of experts. In a really extreme example, you can have something like a system administrator that does normal system administration. And then you can have a security administrator that is just responsible for the security of the system and the policy itself. Or you have a security team in your organization that mandates a certain security policy on all systems, and they are responsible for taking care that this policy is actually safe. So you can split this up. Then, since the policy is something that you centrally load, it's really easy to review. You have this one policy, and you know if this policy was loaded 5 minutes ago and it's still loaded, then in between you had this state on your system. That's not really possible with discretionary access control, where it can change willy-nilly at all times. And you can have very fine-grained access control if you need it. So in an extreme case, you can do things like compartmentalization, where you say you're all part of some team, you all have a top secret clearance, but only this part of the room is part of a certain project. Only you have a need to know for a certain project, so only you get the information for that. That is something that basically SUSE was built for, since it was built by the NSA. So you can do something like that with SUSE. Of course, nothing in life comes for free, so it also has a couple of disadvantages. So it is harder to understand, and after the talk you will probably understand why. It's mainly a thing that it's just a different way of thinking about access control than what you're used to if you're a normal Unix user for a long time. It's more complex to administrate. That's kind of self-evident truth here, because it is an additional layer that you need to administrate. I think it's worth it, but of course it is additional complexity. And the main problem really is missing experience. Like pretty much everyone that has zero SUSE knowledge comes in touch with SUSE the first time something breaks, which is not an awesome time to learn about something. So that is a big problem. I hope you didn't have this experience already. So why we still do it then? So first of all, it really increases the security of your system. As an attacker, if I open a box where SUSE is active, I'm not happy. It's way more annoying to navigate this. It is definitely quite an increase in the system security. Also, we would never build operating systems the way they are nowadays. So if you have an Android phone or an iOS phone, they have a different way of dealing with security because they are newer. The older operating systems, like your PDF reader, can access your banking data, because that's the way we built them, like in the 70s. That's not a really good idea, but it's super tough to change something nowadays like that. And SUSE is kind of an attempt to solve this problem by putting a harness around security here. So this is the basic idea. The basic idea is type enforcement. Every object on your system will get a user, a role, a type, a sensitivity, and a category assigned. And if you put this then all together, then this forms this nice colorful string here, a so-called security context. And SUSE does access control from one security context to the other security context. The good news is you can ignore pretty much everything here, apart from the type. So if you see a string like that, then just concentrate on that middle part that usually has that _t behind it. That is the type. For 99% of your needs, you can just think about a type. The other parts are obviously also not useless, but like in the beginning, just think about a type. Pretty much everything on your system will have a security context attached. You will have it on sockets, on packets. There are over 130 different security classes. So pretty much every part of your system will be confined in some way by SUSE. Not everything is active by default, but you can do a lot more on top if you want to. If you want to see information about SUSE, then usually adding a capital Z to the command line will either cause the command line command to show you information about SUSE, or to do the right thing when it comes to SUSE. So here again, we list the shadow file, and we see here the security context. And again, you can ignore everything, just look at the type. The shadow file has the type shadow t. We do the same thing now for processes. We grab for the postfix master process. It's cut off a little bit, but there you see here the security context, and again, just the type postfix master t. Usually, you should have a really good correspondence between the type name and the object you're looking at. Like if your shadow file has the type postfix master t, not so great. You will probably run into problems. From a basic point of view, you first have normal Linux access control. So DAC comes first. If DAC does not allow something, then SULinux does not come into play. If I, as an unprivileged user, try to read the etc shadow file, this will not cause an SULinux denial because it's already forbidden at a lower level. Only the access that are allowed by DAC will come into play for SULinux. And SULinux is a little bit like a well-configured firewall. It's denied by default. So it forbids everything, and then you poke holes where you actually need them. And it's even more like a firewall because it's a little bit like a firewall for system calls. Quite often you have a pretty good correspondence between the system calls that your workload issues and the SULinux policy. If you read a file via a read call, then you will a read permission in your SULinux policy. It's not always one-to-one, but the correspondence is pretty close. On the systems where we use SULinux, so SLE 16 and everything that's built on top of that, we also provide an SULinux policy. And we provide actually two. We provide the targeted policy, which confines pretty much everything in the system. And we also provide the minimum policy. And I kind of get an echo. Can we reduce this a little bit, please? By default, you get a targeted policy, and I would also encourage you to stick with that. But if you have a very specific use case, you might switch to the minimum policy and then only confine what you want to confine. No? The policies consist of different modules. We have around 440 modules in the targeted policy. You can add and remove them as you need them. And they can be written in two different ways. You can either use the normal SULinux basic language where you say allow this type and this type on this object, these permissions. That is a bit like assembler programming. You can do it, you should not do it. Or you can use the abstractions that you get from the policy where you say read the random device from this type. Then you don't have to care about all of that. You can basically think on this abstraction level, and that's the big advantage because you express intention, not necessarily the technical detail here. Sooner or later, you will see something like that. An SULinux denial. It's a long string, so I've broken it a little bit up. So we see something try to transition here. We see a source context and a target context. We see it was a process. And then we see some additional information here. And especially in the beginning, it will be very difficult for you to read. But the good news is that these AI tools are super nice in explaining those actually. They're not really good in writing policy modules and stuff like that, but they're good in explaining what went wrong here. So in this case, you see there was the SSH daemon and a certain shell, but we see something was kernel. So something is definitely mislabeled here. No? So if you come across an SULinux denial, you have a couple of options here. First, what you should do is consider what you're doing. If your security system tells you no, your first reaction should not be, oh yes, I will definitely do it. If your seatbelt is holding you back, you don't cut it off. So think about, am I maybe doing something wrong? That is a good first step always when it comes to that. If you definitely want to do this, and if it makes sense, then quite often you just need to change some types. So these file types that I showed you, for example, if you create a file in your home directory, it will get a type that corresponds to your home directory. If you now move it into etc as a configuration file, then it might still have the type of your home directory. So that doesn't work. So relabeling the system, fixing the types, that is a good first step. Then there are tools like audit to allow, which I will explain on the next slide in a little bit more detail. And if everything breaks, then you can set either the system or single processes to permissive. That means that the SULinux rules will cause violations, but they will not prevent anything. And of course, I would very much prefer if you do this for single processes and not for the whole system. No? But for testing, doing it for the whole system like that is fine. Apart from that, it's much better to say, well, we have a problem with OpenVPN, so just disable it for OpenVPN and not everything. No? And if all of that doesn't help, then open a bug, then we have a look. The policy is pretty good by now, but sometimes just stuff breaks or you're doing something that we've never seen before. That's also very much possible. So, audit to allow, the magic tool. it allows you to take these SUSE denials, pipe it into order to allow, and it will then give you the rules that would be necessary to actually allow that. The good thing about it is aware of the policy interfaces. So it will not give you like these basic SUSE rules that I showed you before, but it will find the right interface calls and give you those. So it will give you an okay-ish module. And it is also aware of the so-called booleans, which are small toggles that you have on your system, where you can change the behavior of your system. And the prime example here is, if you went to university, then you have probably experienced that you had some home directory and you had a folder in there, and if you placed files on this folder, then some web server served them out, so you had your small private page. That requires the web server to actually access your home directory, which is not a good default, because by default I would strongly prefer that the web server is not allowed to access any home directories, but for this use case you have to do it. So there's a small toggle in there that you can set to allow an arbitrary web server to access home directories. And order to allow is smart enough to actually recognize this, like, you don't have to create a new module, you can just take this boolean, set it, and then you're done. So really good thing, but again, super helpful, but please try to understand your problem first. I've actually seen people that had a while loop running in the background, taking all the SUSE denials, piping it into order to allow, and then automatically loading the module. Yeah, it works, but it's really not the way how you should use a security system. Yeah. Good, so why did we actually do it? We had UpArmor before, and UpArmor is a good security system. And SUSE is a good security system. It's not like one is bad, the other is better, but we've seen that SUSE got quite a bit more traction in the last couple of years. Like if you use an Android phone, for example, you all use SUSE. It's the default mandatory access control system on there. If you root your phones, you know that it became a lot more annoying since SUSE is there, because it is definitely harder. But it is a good security measure. Especially when you run some high security environment, then you probably have an easier time with SUSE. You could do pretty much everything also with UpArmor, but after a while it becomes a little bit tedious to actually get to the point where you need to be. SUSE was kind of designed for these places, so you can do pretty crazy stuff if you want to. You can add security labels to your network packages that travel to other systems, and they then act on that, so it really allows you to do a lot. Also, we have a really good coverage with the policy that we ship. So we have these 440 modules. We had way fewer UpArmor profiles, because with UpArmor we concentrated on the network-facing daemons, which are the prime attack surface, of course. But still, with SUSE, you will get a lot more coverage by default. And for most of you, if you don't do crazy stuff, you should not notice it. Don't quote me on that, and don't come back and hold me responsible for it, but for most people it should be the case. So what does it mean for you? That depends a bit on where you actually are. So if you will, no matter what, you will need some basic SUSE knowledge if you're a person that actually works with the systems. If you're a PM or a manager or whatever, then maybe not. But if you're a technical person that works with the systems, you need a basic understanding of SUSE. This talk here is a good start. With a bit more reading, you will already be at a place where you understand the problem far enough to know, am I the problem or is the policy really the problem? And then you either open a bug or not. If you only use the existing UpArmor profiles, then it's easy for you. You can just go from 15 to 16. You don't have to adjust anything. You will get better coverage with the SUSE policy. That's kind of the happy case for you. If you have customized UpArmor profiles, then it's a bit more difficult. So first you need to check if the current SUSE modules that we ship cover your use case. That might very well be the case. No? If you have something built custom for your workload, then it's kind of unlikely. Then you have two options. You can either build your own SUSE module, which is not a trivial task if you want to do it well, or you could just containerize your application. Because if you already containerized your workloads, then you're likely good, because SUSE has very good support for VMs and containers. So when you use containers and VMs, then I told you to ignore everything apart from the type, then the other fields come into play, because they are then used to not only protect the host system from your container, but also protect containers from each other, to make sure that if two containers are running, that they are not able to attack each other. And instead of writing an SUSE module, you might spend the same effort of just putting your stuff into a container and don't have to write an SUSE module that you don't also have to maintain. So might be worth considering. Yeah, and if you disabled AppArmor until now, then remember I'm a security guy, don't tell me stuff like that. Yeah, that makes me cry. I would also strongly encourage you to not do this. I know that if you have to fix something and SUSE breaks your workload, then it is tempting to just disable it. But from an attacker point of view, I can guarantee it is much harder to deal with an SUSE enabled system than with a system that does not have SUSE enabled. So please, please don't do it. And especially now, we have that little upcoming problem with AIs, like finding security issues has become kind of easy, which is on the one hand pretty nice, because I want to fix all the security issues. The problem is we have a tiny amount of security issues in the tiny code bases that we have. So I think the next 12 months are going to be pretty interesting. And in my mind, the only way to deal with that is to concentrate on the fundamentals of like segregating and isolating and least privileges, like the stuff that we should have been doing all along. And SUSE is a prime example of that. Like if you have a really tight SUSE confinement, then if someone breaks into your machines because they have the 0-day that they got by asking Claude to just provide it, then they hopefully can't move from there, or you will be able to see it, which is also a huge advantage. You will probably not be able to prevent any attack, but you need to be able to deal with these attacks.
Did you get access to Windows?
We are working on that. But in the end, it doesn't make so much difference, because the current models are already pretty good. So we started to evaluate this a year ago. At the time, they were kind of disappointing still. By now, they are super good. So I find bugs by accident. So last week, I tried to build a harness for something else. Had some source code lying around in this directory from a previous experiment. It found security issues that I did not want to find. It just said, and look at this. It's exploitable. Here's exploit. Great. No. So it's a fun time to be alive. Good.
For now.
For now, yeah. I will now show you how that actually looks in practice. And this is now going to be a bit tricky, because I need to do this with one hand. I did not really count on that. So let me see how this works. Okay. What you see is a virtual machine that I'm running. On the right side, you have, I will tail the audit log, and then I will grab for AVCs, so for these SUSE denials. You can do that in a lot of different ways, but it's basically a nice way to see if something pops up in the audit log that you would like to see when it comes to SUSE. And what I'm doing here is first I set the system in permissive mode, because what I'm doing after that is something that SUSE would deny right from the beginning, but I want to set up this reverse shell that I'm doing here. So I'm basically opening a reverse shell as the name caching daemon that is running on most systems to cache DNS lookups and stuff like that. And I'm binding this to port 1234. So an attacker basically hacked into this daemon and now has a way to control it. That's what I'm simulating here. So it's running now. You can ignore these denials for now, because that's basically just for the demo setup. So let's scroll it away. And what I'm doing now is that I set the system to enforcing again, because otherwise we can't really demo the problems or the protection. And then I connect to this reverse shell that I just created. And now I'm here on the system. I can check my status. And I already run into problems, because that should give me an error. I don't know why this doesn't work now. Live demos, great, I love them. Yeah, let me 1 second, I need both hands. Okay, yeah, sometimes you should record a demo. What you should see now, and I mean, I kind of demo it here, but it's unfortunately not really visible in the logs. I tried to just list the root directory and it doesn't work out because SUSE does not allow it for this daemon. This daemon has no need to list the root directory or do anything else. You would not be able to see other processes, you would not be able to access any other directories. And the thing that I actually wanted to show you, because that's one of the main advantages that is quite often ignored when it comes to SUSE, you should see a storm of AVCs here, so of these SUSE denials, because everything you do here will cause a huge number of SUSE denials. And if you have a well-managed environment, then you can use this as a high-value signal that something goes wrong. Yeah? It's not always the case. It might also be your junior admin that does something strange, but then you maybe also want to discuss it with him. But in most cases, if you see a huge spikes in AVCs, then maybe something is off on your system. Yeah? So this is something that a lot of people unfortunately kind of ignore. They just try to get SUSE to work somehow and then forget about it. I would highly recommend to have a look at these AVCs and monitor them in your intrusion detection systems. If you see a spike, like for that demo, if it would work, you would see now 100 different SUSE denials that pop up just by me looking around, like who am I, which processes are running, like the normal stuff that attackers do when they come onto a system. Good. So next time I will record that, and with that, I can go back and thank you for your attention and open it up for questions. And I will hand out the mic, so you were the first, because it is super difficult to hear for others.
So you've enabled targeted policies. Are there any plans to enable MCS or MLS policies?
We, at the moment, don't ship them, but we are considering if we want to. So if this would be interesting for you, then please tell us. At the moment, we did not really have a lot of users, and it is quite a bit of additional testing effort for us. So we don't ship them at the moment, but we are definitely open to reconsider that decision. Okay, I think you were next. No? Okay, be careful.
Well, you told us how to get to the commands, what should be enabled with the audit to allow. It tells us what to do, but how do we see what is actually going wrong?
The root cause is something that you basically need to figure out on your own, but there, like AI is super great. They are really good by now. That also changed quite a lot in the last couple of months. That is what I meant with you need a certain amount of SUSE experience. There are a couple of, there's for example SE troubleshoot, which is a daemon which tells you what went wrong. For simple cases this works. But most of the time you need to have an understanding of your system and debug the process as it is happening to understand why something is going wrong. There's unfortunately no silver bullet there. We are currently playing around with AI models to see if they can automate this to some extent, but the last time I tried, they were not great in those things. But that can be different in a week, like we live in a crazy time.
Thank you.
Other questions?
Also close to the speaker, so let's see. For deeply virtualized systems, how would you recommend to set up SE Linux on the host and on the guests?
Yep, so on the host it's easy, I would say, because there with the default configuration you already get a pretty good confinement. It will, it has dedicated types for that. It will then also split out. I mean, you can just go quickly back to this slide here. So what SUSE does for different VMs and also containers is it uses these categories, and it will then assign different categories for different running virtual machines. And with that you have one type for I'm basically a running virtual machine, but the different virtual machines will be separated by different categories. So with that, you protect the host from the VMs and the VMs from each other. And then, of course, it would be good to also have SE Linux in the VMs itself. Yeah.
Do you protect the VM as well with SE Linux? So is SE Linux on the VMs also?
Depends on how you configure it. So the question is if it's also on the VMs. I, as a security person, if I would be in your security team, I would tell you put SE Linux everywhere. Because your VM will probably expose the service. This is the thing that I will be attacking as a hacker. So I will end up in your VM. Then I will own the VM, which is harder if SE Linux is on there. And then I might try to break out from the VM and attack the rest of your system. But there it becomes kind of difficult. I mean, not many groups are.
Hypervisor out, breaking out from the hypervisor is rather difficult.
It is rather difficult. I mean, there are groups that are capable of doing something like that. You always have to consider what is basically your threat model. Like, if you're against three-letter agencies, then yes, that's a problem for you. And also, again, AI makes this kind of accessible to a lot of groups that did not have this capability a couple of years back. Like, also, it changes kind of the calculation because finding these vulnerabilities and exploiting them is not trivial. Like, we're not living in a time where it's super easy to code and exploit. Usually, you need like a dedicated team for that and combine different vulnerabilities. They are like, you get a lot of money when you sell them. Like, some of these exploits bring you a couple of millions. They usually don't want to waste that on some random WordPress page. But if your use case is like protecting the healthcare data of a country, you might be a worthy target for that. Okay, any other questions? That's great, we're already over time, so thanks again for the attention. If you have questions, you can come to me during the whole conference and I'm happy to discuss.